Okay guys, we're gonna solve problems in this session, problems regarding y delta transformation. So let's begin from the simplest one. As you see, this is a y network, like this is a y or t network, a y network. So we need to transform into the equivalent delta, the equivalent delta network. So the interior part is the y network. So we need to calculate the corresponding registers on the delta network. So let's begin from RA, the corresponding registers on the delta network. We're gonna multiply just each possible two resistors, and divided by the resistors on the opposite on the y networks. So as you see, this is the formula. So in order to calculate RA for this network, we're gonna multiply each resistors, each possible two resistors divided by the corresponding resistor on the opposite part of the resistor we need to calculate. For example, in order to calculate this one, in the sum of the product of each two resistors divided by this one, because this one is the resistor on the opposite part. RA is R1 times R2 plus R2 times R3 plus R3 times R2 divided by R1, the opposite. So RA is 10 times 20 plus 20 times 40 plus 40 times 10 divided by the opposite. The resistors on the opposite side is 10. So the value will be 140. The value of RA is 140. So in order to calculate for RB, we're gonna add each possible product of resistors on the y network. So divided by the opposite resistor. So this is the product is divided by 20. By the way, the numerator is common for all corresponding delta networks. The numerator is common, so the denominator is the opposite resistor. So for RB, the opposite resistor is 20, the numerator is the same, so divided by 20, the result is 70 ohm. So RB is 70 ohm. So for RC also we do the same, divided by the opposite resistors. The opposite resistor is 40 ohm. So 40 ohm, the result is 35 ohm. This is how we calculate. So let's come to the second problem. This is the question. We are asked to calculate the equivalent resistor, RAB between these two terminals. This a bridge circuit. So we are asked to find RAB, the equivalent circuit, and the current I of the current I after we calculate the equivalent circuit. So we need to reduce a part of a circuit, or to transform a part of a circuit from delta into Y, because this is a bridge. We can't find the equivalent resistor between these two, because they are neither in series nor in parallel. So let's transform this part of a circuit. So the lower part of the bridge, this is a delta network. So we're going to transform this delta network into a Y, the equivalent Y, the corresponding Y circuit. So as you see, this is the outer which we take out of this is the network of delta. So 5 ohm, 15 RB, and 20 RA. So this short circuit is reduced into a single junction. So when this circuit is transformed into Y network, as you see, we will find resistors in series, because we substitute this delta network into the corresponding Y network, as you see. So we will find series, also series, this part is in parallel. So we're gonna simply calculate the equivalent circuit after we transform. So first let's transform. To calculate R1, we're gonna multiply the adjacent parts. The adjacent parts RB times RC. For R1, RB and RC is the adjacent parts divided by the summation of the 3 resistors. So this will be 5 times 15 divided by 5 plus 15 plus 20, which is 15 over 18, which is 15 over 18 for R2. R2 is this one. For R2, we multiply the adjacent resistors 5 times 20. For R2, 5 times 20 divided by the sum of the 3 resistors, which is 40. So 40, the result is 5 over 2. For R3, to calculate R3, we multiply the adjacent resistors. These two are the adjacent resistors, 15 times 20 divided by the sum of the 3 resistors on delta, which is 40, 15 over 2. So we will replace these 3 corresponding values, as you see, these 3 into 3 corresponding resistors. These 3 will be replaced for the delta network. So after that, we will simply calculate the RAB, the resistor, the equivalent resistor between these two, across these two. So these two are in series, as you see, these two are in series. So the result is, we're gonna simply add them because they are in series, which is 14.375. Also these two are in series. The result will be 10 plus 5 over 2. We're gonna simply add them, 12.25. So the sum of these two and the sum of these two, the branch on these two, are in parallel, as you see, because these two branches are in parallel. So the resultant will be the parallel. We calculate for the parallel resistor 6.686, which is calculated into 6.686 to make it clear. So as you see, the circuit, this circuit will be, this circuit is reduced into, the circuit is, this circuit is reduced into this form. So these two are parallel now. So to resolve for the resultant, the RAB for these two circuits, the product of the two resistors divided by their cell. So the value will be 6.68. So the value will be 6.68. 6.68 and 15 over 2. Now these two are in series. We simply add them. The value 6.686 plus 15 over 2, which is 14.2. So now this is also further reduced into this form, 14.2 in parallel with 30. So the resultant for these two is calculated to be the product of the two resistors divided by their sum, which is 9.632. RAB will be 9.632. The final value of the resistor is 9.632. So in order to find I, the current, this current, in order to find the current, I is the current I right here. The current flows in, emerges out of this one, is calculated by, so V, the total V, the supply voltage, which is 120 divided by the R equivalent, which is equal to 120 divided by 9.632, the equivalence RAB. So which is equal to 12.463 is the final answer. So this is how we can calculate. Thank you.